Get ready for a cosmic mystery, cat lovers. You see, cats freak out when faced with a closed door. Who knows what's on the other side? Similarly, us humans are obsessed with exploring beyond our solar system, just like Voyager 1 and 2 have been doing for over 4 decades. But here's the mind-blowing part. We'll never know if these space travelers actually left our cosmic neighborhood because their signals will soon fade into the vast unknown. Buckle up, space fans. Despite being a whopping 13.8 billion miles away from our sun, those tiny but mighty Voyagers are still just scratching the surface. Only about 1,000th of the way to the solar system's edge. And get this, it'll take Voyager 2 an astonishing 30,000 years to reach the Oort cloud, a far-off cosmic neighborhood where comets hail from. But don't worry, the real magic is in what they've already sent back. Like that otherworldly plasma hum in interstellar space, which Voyager 1 caught between 2012 and 2013, and is now filling your speakers right now. Mind blown yet? Both Voyagers are still sending back crucial info from the solar system's deepest unknowns. Did you know that way back in 2012, Voyager 1 crossed into the heliosphere's edge, a vast bubble of solar wind plasma? It was then that its sensors stopped picking up the solar wind's direction. The boundary between this bubble and interstellar space is called the heliopause, where our sun's solar wind meets the cosmic medium outside. On one side, you have the sun's magnetic field and solar wind. On the other, a sea of interstellar plasma and protons with their own magnetic fields. Get ready for more cosmic surprises. So, after leaving the sun's bubble in 2012, Voyager 1 discovered that high-energy particles from outside were seeping in. Meanwhile, it also found a magnetic field from beyond our solar system. Fast forward to December 2018, when Voyager 2 made its own heliopause, crossing at an impressive 119 astronomical units away from the sun. But here's the twist. This little space explorer found that solar material was leaking into interstellar space. In other words, particles from outside were entering our solar system's bubble, and Voyager 2 detected those solar particles on the other side of the heliopause. Scientists are baffled by one more finding. Why did Voyager 1's border seem thicker than Voyager 2's? The mystery remains unsolved for now, but the hunt continues to unravel this cosmic enigma. But here's where things get really fascinating. Drucher Edward Stone, leading the team, analyzed both space probes' findings, and what they discovered left everyone stunned. Our solar system's protective bubble, known as the heliosphere, doesn't have a fixed border. The boundary between our solar system and interstellar space, called the heliopause, isn't steady. Instead, it shifts back and forth depending on solar activity. In Drucher Stone's own words, the solar system breathes. This mind-blowing revelation makes you wonder, how could two spacecraft crossing this boundary at seemingly similar points produce such different results? The data from Voyager 1 and Voyager 2 paint a complex picture of our dynamic solar system, full of mysteries waiting to be unraveled. So, what's behind these differing results from our brave space travelers? Scientists think it all comes down to timing. When exactly they crossed into interstellar space, Voyager 1 made the journey during the solar system's calm phase, or minimum, while Voyager 2 ventured forth during a burst of activity known as solar maximum. Could this difference in timing have affected their paths? Maybe. Also, consider this: each spacecraft entered interstellar space through different areas. Voyager 1 sailed into the southern hemisphere, and Voyager 2 cruised into the northern, with 6 whole years separating their journeys. This unique set of circumstances could be why we're seeing such distinct data from these two pioneering spacecraft. One more exciting discovery: once past our heliosphere's edge, both Voyagers found themselves in a region with plasma. Essentially, charged particles that was packed much tighter than the plasma inside our solar system's bubble. In fact, Voyager 2 even spotted a 20-fold increase in density and temperature just beyond our heliosphere, revealing this interstellar space as a dynamic, not static environment. But here's where things get really fascinating. Voyager 1 detected a temperature of about 90,000 degrees Fahrenheit, which is way hotter than scientists predicted, ranging between 27,000 and 54,000 degrees instead. This was a major surprise, and that wasn't the only shock. As our Intrepid spacecraft approached the edge of our heliosphere, it found something truly remarkable. The magnetic field just outside wasn't drastically different from what's inside near the heliopause. In fact, these field directions were almost identical, which completely defied scientists' expectations. The news was so astonishing that researchers even questioned whether Voyager 1 had actually crossed into interstellar space at all. But wait, there's more. Voyager 1 also discovered a significant boost in magnetic field strength, almost doubling it. And not only did this happen suddenly at the edge of our heliosphere, but Voyager 2 confirmed these findings as well. What's even crazier is that within the margin of error, the direction of the magnetic field doesn't actually change when crossing into interstellar space. It remains largely the same. Scientists were also stunned to be able to measure the magnetic field strength outside our heliosphere, with Voyager 1 detecting a whopping 0.49 nanoteslas and Voyager 2 measuring 0.68 nanoteslas. And guess what? This phenomenon still has scientists scratching their heads. They've yet to find a satisfactory explanation for this mind-blowing discovery. But here's the thing. Scientists think that the interstellar space right behind our heliopause might still be feeling the solar wind's impact, causing some serious turbulence and making the magnetic field strength vary in different areas. And while we're talking about the edge of our cosmic bubble, let's also dive into pressure data. It turns out to be a whopping 267 femtopascals, which is way less than what we feel on Earth, but a whole lot more than astrophysicists had originally predicted. To give you an idea, that's 260, 7 times smaller than the tiniest unit of pressure measurement. But wait, there's more. Scientists also measured how fast sound waves would travel through this interstellar medium, and it's mind-bogglingly fast, a scorching 314 kilometers per second, or 195 miles per second. Check this out. Voyager's speedster data is giving scientists an incredible edge in understanding our cosmic neighborhood. But there's still a ton we don't know about interstellar osmosis. That's right, it's a real and unexplored field of study. Unfortunately, the Voyagers are running on borrowed time. By mid-2020s, their plutonium batteries will kick the bucket, and they'll lose contact with Earth. As their power fades, scientists will start to systematically shut down their devices, marking an end to an era of interstellar exploration. The million-dollar question: what secrets lie beyond our solar system's boundaries? Sadly, these space pioneers won't be around to find out. Let's zoom out. We're talking about the edge of our solar system's backyard, the Oort cloud, where tiny objects dance under the sun's gravitational pull, stretching out a whopping 200,000 astronomical units away. As the Voyagers venture into interstellar space, it's the perfect chance for us to unravel some heliosphere and heliopause secrets back home. But there won't be any postcard-worthy pics from this cosmic frontier. In fact, we've been camera-shy since 1990 when NASA's Susan Dodd confirmed that our spacecraft cameras were officially retired, all in the name of saving device memory for more crucial tasks. Let's take one last look at what we've sent out into the universe, that iconic pale blue dot photo where Earth is just a teeny tiny speck. But even when the systems shut down and batteries die, our intrepid Voyagers won't be saying goodbye just yet. They'll keep on going, carrying out an intergalactic mission to represent humanity in case of an alien encounter. Basically, they're cosmic ambassadors. On board, there are 2 shiny golden records with a message from us, featuring sounds, images, and info about our planet. Will these records find a new home among the stars, or will they be forever alone out there? And as for our descendants, will they ever uncover what happened to the Voyagers after we lost touch? Only time Zellers in space will tell. Don't forget to hit that comment section below. Share your theories on the record's cosmic fate. And don't miss out, let's keep this mission alive.